Hi guys, welcome to video number 3, and we're going to start here with number 21. Write the equation of a line in standard form. So we want it in ax plus by equals c. That has a slope of -4/5 and goes through the point -15, 2. Well, I am given a point and a slope, so it would make sense to start with point-slope form, which is y minus y1 equals mx minus x1. So let me plug in what I know. This is x1 and y1. Y minus 2 equals my slope, -4/5, x minus -15. So this becomes a plus, and my goal is eventually get it to standard. So let's distribute and keep simplifying. Y minus 2 equals -4/5 x. Remember, this is 15 over 1. So if I multiply -4/5 times a positive 15, it would be a -4 times 5, or a -60 over 5 times 1, which is 5. So that's y minus 2 equals -4/5 x minus 12. This simplifies to be 12. If I want to keep going into y equals mx plus b, for the sake of habit, I add the 2. And so far, my equation is y equals -4/5 x minus 10. Now, notice that is an answer, but if you pick B, that is not in standard form, so we're not there yet. Standard form cannot have any fractions or decimals, and so what we need to do is get this into this format and have the x go first. So I'm going to add the 4/5 x to the other side, and I'm going to get 4/5 x plus y equals -10. We can't have fractions though, so the 5 is the reason that the fraction exists. So what I'm going to do is multiply the entire equation by 5, distribute it to everything, and so my final answer would be, so 5 times 4/5 is just 4x plus 5y equals -50, which is A. So my answer is A. If you need to pause and rewatch this one, feel free. I know there's a lot to it, so please take your time. Number 22, find the equation of a line in slope-intercept, or y equals mx plus b, that is parallel to y equals 2x plus 3 and passes through this point. So we want an entirely new equation. So in the end, I'm going to be using this formula again. But first, if my current line is y equals 2x plus 3, my current slope is 2, or 2 over 1, which means that my parallel slope also has to be 2, or 2 over 1. If you remember, parallel lines never touch, and the reason they don't is because they're going or rising or falling at the same rate or same slope. So the slope I'm going to be using is 2. It has to pass through 9, 5. So I would have y minus 5 equals 2 times x minus 9. If I want it in y equals mx plus b, I have to distribute and keep simplifying. Y minus 5 equals 2x minus 18. Add the 5. So my final answer is y equals 2x minus 13, which is B. Number 23, what is the slope of a line perpendicular to the graph of 6x plus 7y equals 42? Well, remember, this line is still in standard form. So the first thing we need to do is convert that to y equals mx plus b so that we could see what the slope is before worrying about what the perpendicular slope is. So first things first, if I take this equation and I solve for y. So if I subtract my 6x, 7y equals -6x plus 42. Then I divide everything by 7. My equation would be y equals -6/7 x plus 6. So that means that my current slope in my line is -6/7. So my perpendicular slope means that my lines are hitting at a perfect right angle. In order for that to happen, my slopes need to be opposite reciprocals of each other. So that means I take my fraction and I flip it, and the sign changes as well. It's originally negative, so it becomes positive. If this was originally positive, it would become negative. So my answer again is B. Number 24, write the equation of a line in point-slope form this time that passes through the 2 points, -3, 5, and 7, -11. Well, if I want point and slope form, I need a point and a slope. I definitely have a plethora of points, but I do not have a slope yet, so I need to find it. So y2 minus y1 over x2 minus x1, which is a -3 also. So this becomes a big old plus sign. So -11 minus 5 is -16. 7 plus 3 is 10. If I divide both of these by 2, my slope is -8/5. So this does not have a slope of -8/5, so bye. This one doesn't either, so see ya. So we're between A and B for my answer. So let's take a look at part A, see if this one makes sense. It looks like we're using this slope and this point. So if I were to plug this point and that slope in over here, we would have y minus 5 equals -8/5 x minus -3. So then this would be a plus. Notice, this example gave you a minus, so this answer is wrong. I'm guessing the answer is B, but let's check it. I have an obsession with B here, but that's fine. So if I check this point, if I plug the 7 in for the x, yes, that's correct with the subtraction. If I plug it in the formula here for the negative, yes, it changes to a positive. So my answer again is B. Number 25, this is the newer material we just did. Which relation below is a function? And remember, the domain cannot repeat. What this really means is, think about, before we do this problem, think about the equation y equals 2x plus 1. If I say that x is 3, if I plug 3 into this equation, my output value, or 2 times 3 plus 1, should be 7. So every time I plug in a 3, my answer out should be a 7. If I plug in a 3 and I get anything else out, that doesn't make sense. So if we plug one number in, we have to get the same number out each time, which brings me to 25. If I look at A, here I plug 5 in and I get out a 3. Here I plug 2 in and I get out an 8. But here I plug 2 in and I get out a 1. So it's not possible to plug 2 into an equation to get 8, then plug 2 in it again into the same equation to get 1. So my domain, or my x value, is repeated, so this doesn't make sense. Part B, if I scan this, 5 goes to 3 the first time, but then 5 goes to 7 the second time. It doesn't make sense. Part C, -5 goes to 3 the first time, -5 goes to -1 the second time. Doesn't make sense. D, though, if I look at all my x values, there's never a time that it repeats. And there's never a time where a point doesn't make sense. So this one must be my function. What are the domain and range values of the answer we chose? Please make sure to check it's correct. So D is my correct answer. So my domain represents all my x values that are within this set. So my x values are 5, 2, -5, 4, and -2. And what this is a kind of a strange looking bracket. My range represents all my y values in my correct answer. So that would be 3, 8, -1, 7, and 1. So make sure that you know how to list domain and range values for the final. Number 27 asks the same question a different way. Which relation is a function? And my hint to you is, remember the vertical line tests, that your x values cannot repeat again. So what you're going to do is look at all these examples and see if the vertical line test fails. For instance, if I look at B, if I draw a vertical line at 1, 2, 3, here is one answer and here is another answer. I can't plug in 3 and get both of these at the same time. So that fails the vertical line test because it hits the graph twice. C, if I draw a vertical line right here, it hits that dot and the graph. Hits more than one time, so that fails the vertical line test. Part D looks like a bunch of steps, but wherever I draw a vertical line where the steps are changing, if you look here and here and here, this hits the graph more than one time because there's infinite points here, so that fails the vertical line test. However, part A, no matter where I draw a vertical line, all the way down this graph, it only hits the graph at one point for each vertical line. So this passes the vertical line test, so A is definitely our function. Number 28, solve the system of equations by graphing, then find the point of intersection. So if I would like to graph this, I know a lot of you like to solve it for y equals mx plus b. So this equation, let's get y alone, shall we? So it'd be y equals negative x plus 3. So if I graph that, I would start at 3, then my slope is really down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. So this would be my first line here. My second line, if I again solve for y, we have 3y equals x minus 3. If I divide everything by 3, I would get y equals, remember that there is a 1 next to that x, so the slope here is 1/3 x, 3 divided by 3 is 1, so this is my second equation. So I would start down 1, and then I would go up 1 over 1, 2, 3. Looks like I found the intersection point already. If I draw my blue line and connect, looks like my point of intersection is right there, which is at 3, 0. How many solutions does this system have? Well, my options are either one solution, infinite, or none. And because I see it intersect once, it has to have one solution. What vocabulary terms best describe the situation? Well, it was either independent, dependent, inconsistent, and consistent. Because these lines are doing their own thing, one of the vocabulary terms is independent. The other vocabulary term between consistent and inconsistent, there is an answer, which means that the other vocab word must be consistent. Number 29, use substitution to find the system. This is probably the last one we're going to do in this video. Substitution, to replace. So the first equation is y equals x plus 3. So in the second equation, anytime I see a y, I'm going to replace it with x plus 3. And I'm going to solve for x first. So I'm going to distribute that negative 7. 8x minus 7x minus 21 equals 12. I'm going to combine like terms and get a 1x minus 21 equals 12. Add the 21. 1x, or x, is going to be equal to 33. So we have x. But if I would like to find y, I'm going to plug it back into the quicker of the two equations. I'm going to plug 33 in for x now. So y is 36. So my point would be 33, 36. And if you're interested on this test or on the final exam, remember, this is a point x, y. So you could take 33, plug it in here, take 36 and plug it in here, and see if this equation's true. You could take the 33, really do like 8 times 33 minus 7 times 36. And if you do that, that should equal 12. If it doesn't, you know your answer isn't right. All right, guys, in the last video, we're going to start with number 30. Thank you.